In this video, we're going to look at graphing linear equations by finding the slope and the y-intercept. And then we're going to use those pieces of information piece by piece to build our line. Now, in order for us to find the slope and the y-intercept, we need to look at putting this equation into slope-intercept form. So remember, when we talk about slope-intercept form, we are talking about y equals mx plus b. So once we're in the slope-intercept form, this coefficient of x will give us our slope, and the b will give us the y-intercept. Now remember that the y-intercept is a point, and you must give the point as an ordered pair, so that would be 0, b. So right now we can't identify this stuff that easily until we solve for y. A lot of students will say, oh, the slope is 4 because that's the coefficient of x. No, it's the coefficient of x after you have solved the equation for y. So that's what we're going to do first. We're going to rewrite this equation underneath. So 4x minus 3y equals 6. And we're going to take the steps to get y by itself. The first step is to move the x to the other side. So we just subtract 4x on both sides. Please make sure that you understand that these guys here are not like terms, so don't try to combine those. So now we have negative 3y equals negative 4x plus 6. And we finish getting y by itself by dividing everything by negative 3. Now, you could just do one big fraction bar over here and have everything over negative 3, but I don't think it really helps us out too much because we want to be able to see things separated where you've got your x term followed by your constant term. So by doing individual fractions like this, it should make it a little bit easier for us. And so now y is equal to negative divided by negative is positive. Yes, those guys can reduce. So it's just a positive now. 4/3 x. And positive 6 divided by negative 3 is negative 2. Alright, so now that this is in slope-intercept form, we can see that this is the coefficient of x, and so this is going to be our slope. So my slope is 4/3, and remember that whenever we talk about slope, easy way to think about slope is to say rise over run. It's a ratio of how much you're going in a vertical direction versus how much you're moving in a horizontal direction. Alright, now the y-intercept. A lot of students will say that the y-intercept is negative 2, and that's incorrect. If you were in my class, you would definitely lose points if you said negative 2. The y-intercept is the ordered pair 0, negative 2. Okay? Because again, the y-intercept is a point, and when we graph on the xy plane, we need to use an ordered pair to identify the point. Alright, so now it comes to the graphing part. Now, for graphing, you've got two pieces here. You've got the slope, and you've got the y-intercept. The slope is movement. The y-intercept is a location. So you want to start with the location because this is something that you definitely know. You know that you have 0, negative 2. Also, keep in mind the fact that this is the y-intercept. So every y-intercept goes on the y-axis. And if you have trouble remembering which one is which, label them and get in the habit of labeling them every time you use them. So you know that the horizontal one is the x-axis and the vertical one is the y-axis. So every y-intercept goes on the y-axis. 0, negative 2 is right here. And once I've used the y-intercept, I'm not really using that anymore. So this guy is done. What I do is that I use the slope from that point to find other points. So I use this ratio of rise to run, which means I'm going to go from here. I'm going to go up 1, 2, 3, 4 units, and I'm going to go right 3 units. So this is going up 4 and over 3. And you might say, how do you know if you go up or down or left or right? Well, I look at this as a positive 4. So positive rise means going up. I look at the denominator, say it's a positive 3. So positive run is going to the right. So I go up 4 to the left 3. I can plot another point. And I can do the same thing. I can go up 4 units, and to the left, or excuse me, to the right, 3 units. I can put another point. And if I need to get more points by going out to the left, I can do that by kind of reversing things. Instead of going up and to the right, I can go down 4 units, and to the left, 3 units. So I'm going to end up right here. Okay. When it comes to graphing a line, you only need 2 points because you throw a straight edge up on that, and that's going to be a line. I plot more points than that so that things line up very well, because 2 points is going to be great, but if you line it up and you're off just by a little bit, you're going to be accurate between those 2 points, but when you go further and further out, your trajectory is off and you're really going to be missing points. So, I'm going to get this right here. And when you graph anything, you go from edge to edge of your graphing window. Don't just do it in between a couple of points, do it from edge to edge of what you're given. And also make sure that you put arrows on the ends. The arrows on the ends indicate that you are going on forever in both directions. Now we can take time to check our work by identifying the ordered pairs that we have. So for example, this is the ordered pair 6, 6. And we can check that by plugging it into this equation and making sure that what happens whenever I plug it in equals 6 on the right side. So if I check that real quick, that's 4 times 6 minus 3 times 6, 24 minus 18 equals 6. It checks out. And I can do that with any of these other ordered pairs. Okay. Now, for an exam that you're going to take with me, you want to make sure that you follow the instructions. And for graphing, a lot of times I'm going to ask you to plot and identify at least 4 points, 4 nice, clear points. So you would identify this one right here as the ordered pair 3, 2. You have 0, -2 here, and this is -3, -6. So that's all what I mean when I say plot and label points. Nice and easy. Don't do things that have like weird decimal values, because when you do that, I kind of know that you're not doing this on your own. You kind of go into a calculator. But there's no need for a calculator with anything that we're doing here. All right, let's look at another example. So down here we have 2x plus 5y equals -10. And again, I want to find the slope of the y-intercept. So just like we did above, let's rewrite this equation. And let's go through the steps to get y by itself. Of course, the first step is to subtract 2x to the other side. There's not really a lot going on in that step, so if you don't want to actually write that you're subtracting 2x on both sides, that's fine. You do want to make sure, however, that you write the variable part first, followed by the constant, because we're trying to put things in slope-intercept form, and that's just the order that they have there. Finally, we're going to divide everything by 5. If you find that you are losing points, that you're making a lot of mistakes when it comes to these problems, make sure that you are showing each step. So now we have y is equal to negative. Well, 2 over 5 doesn't reduce, so it stays that way. X, and then 10 over 5 is 2. So we see how this is in slope-intercept form. This coefficient of x is your slope. All right, so my slope is negative 2 over 5. And again, we're going to write this over here just to the side to help us remember that this means rise over run. And then to identify the y-intercept, we just look here at the constant. But again, remember the constant is not the y-intercept. It's the ordered pair 0, -2. So this is our scratch work for putting things in slope-intercept form. We identify the slope. We use this to give us the y-intercept. And now I put all the information together, starting with the y-intercept. Remember, every y-intercept goes on the y-axis. So again, here is the y-axis. So the y-intercept is 0, -2, so let's plot that. And then we have a slope of -2 over 5. Now the thing to understand here is that you just have a single negative factor. So a lot of times it's easier to make the numerator the negative part. So that means I would have a rise of -2, which means from here I would go down 2 units and then go to the right 5 units. So that's a rise of -2, so going down. But it's a run of +5, so go to the right. And you can keep doing this. If I go down 2 and over 5, I'm going to end up just off screen, about right here. And I need to get more points. So let's flip things around. Instead of going down and to the right, let's go up and to the left. So from here, we're going to go up 2 units, but now go to the left 5. Do that again, up 2, and to the left 5, so right about there. And as long as we've counted correctly, we should be able to line everything up nicely with our straight edge. And draw a nice straight line, just like that. And again, take time to identify these ordered pairs that you're going through. So way back over here, we have -10, +2. Here is -5, 0, 0, -2, 5, -4. Clearly identifiable points. We could check each of these into this equation. You're going to see that everything works out. So yeah, it's pretty easy to check everything here. One thing to note about slopes is that when you have a negative slope, from left to right, you're going to be going down, going to be decreasing, as opposed to the example we had at the beginning, where you had a positive slope. So this positive slope meant from left to right, you'd be going up. Not only is the slope positive, but it's 4/3, which means between any 2 points you pick, it's always going to reduce back to being 4/3 for this particular line. So if you were to measure, say, from here to here, well, if you look at the rise over run, like if we were to calculate that just by looking at the picture, from here to here is a decrease of 8. And then going from here to here is going to the left 6, so that means a -6. And when you have -8 over -6, the result is a positive, and you can reduce 8 and 6 by a factor of 2, and you get 4/3, which is the same thing we have for slope here. So for this line, no matter what 2 points you pick, when you reduce the slope, you reduce that ratio, it's always going to end up being 4/3. Similarly, for this second example, between any 2 points I pick, the slope must reduce to -2/5. So if I go from here to here, if I look at my rise over run, my rise over run is going down 4 and to the right 10 units. Well, negative divided by positive is a negative, and you can reduce 4 and 10 by a factor of 2, and you're still going to come up with a -2/5. So that's slope and y-intercept. Next, let's check on finding intercepts.